Hello and welcome. I hope you can hear me well. Thank you very much for coming to our today's webinar. This is the last webinar in our series aimed to fill the gaps about the research waste. A year and a half ago, we conducted a survey, identified a few areas of which were lacking in knowledge for important for our health and safety professional. And since then, the environmental and waste management group were trying to acquire specialists to fill the gaps in these areas. So today we will be talking about sustainability in research labs, and Dr. Amy Pickering from the University of Edinburgh, who is at the moment a lab manager and research fellow, will be able to talk about her experience in lab management and sustainability, and hopefully you will enjoy this information. Amy, it's all to you. Thank you very much.
Thank you very much, Olga. Let me just share my screen and we'll get going.
I can see it. I would like to ask everyone to share the questions in the Q&A, and please do not use chat for questions. Only questions from Q&A will be able to be recorded. So the recording of this webinar together with questions will be later on available on IOSH web pages. You will get a link to it. Sorry, Ira.
Great, thank you. Can you see? Yeah, you can see my screen
now.
Yes,
I can see your screen. Thank you.
Perfect. All right, hi everyone. It's really great to have so many of you here. I might apologize a little bit because I've got a bit of a cold today, so hopefully I'm not going to sound too nasal and I'll get this okay. But yes, I am Amy Pickering and I work as a research fellow and lab manager at the Roslin Institute, which we are based at the veterinary campus of the University of Edinburgh. And I work in the lab of Professor Ross Fitzgerald as a microbiologist with an interest in how bacteria adapt to different host species. So I'm a microbiologist by training and I work in a biological lab. So please do forgive me if this talk is a bit biased towards biological labs rather than clinical or chemical labs, but a lot of the things I'm going to talk about are very, very broad. So I'm sure they'll be applicable to a wide range of different types of lab settings. But if you do have something in your own mind that you hoped that I would cover and I don't cover, please do still ask questions about it, because it might just be that I didn't quite have time to fit it in. And I'd love to hear about different aspects of sustainability in your workplace. So the reason that I'm here today is because I have a keen interest in sustainability. And this has mostly been driven by my own concern for people facing increasingly wild and extreme weather events all over the world. And there are many personal things that I try to do on a day-to-day basis to try and mitigate my own impacts on the climate, such as thinking about the way that I travel and what I consume, things like this. But a number of years ago, I realized that some of the practices that I am implementing at home, such as recycling, cutting down on single-use plastic, these weren't really translating into my work life. And so I decided to take some action and start to identify how I could be more sustainable at work. And I think that's something that all of us have a responsibility to do for ourselves and for our colleagues. And so that's kind of where I'm starting from when I talk to you today. And so I really want to start talking today and highlighting why creating a sustainable research lab is an important thing to do. I'll provide lots of examples of energy saving measures that we are implementing in my own workplace and that are encouraged by the University of Edinburgh in particular. And a lot of those examples are coming from work started by the Social Responsibility and Sustainability Department within the University of Edinburgh. I'll also talk to you about a project that I have specifically performed looking at reducing plastic waste in research labs. And as much as possible, I've tried to tailor this talk towards a health and safety perspective, and hopefully I've been able to achieve that quite well. I hope that by the end of the talk, at the end of the webinar, you'll go away with some ideas of things that you can do to implement your own sustainable initiatives within research labs. Let's dive in and think a little bit about why making labs more sustainable is so important. So COP26, which was the United Nations Climate Summit, was all over the news just a few months ago, and it really focused everyone's minds on the challenge of climate change and the global effort that's needed to keep the warming of our planet as low as possible. All the time, I'm seeing more and more scientific reports being published showing that things are worse than we thought. Ice caps are melting more quickly, seas are rising. The number of extreme weather events that can actually be directly linked to climate change is increasing all the time. And we really can't deny right now that a warming world is here and that we need to do all that we can to reduce warming. So I'm showing this image in particular from COP26 because it reminds us that when it comes to the climate, there's no way out. We all need to take responsibility to look to identify how we as individuals can make changes to our lives to aid in the mission of keeping warming as low as possible. And for myself, that means looking at the way that I live my own life, and then also how I do my work and how I make changes at work. And it's really this idea that doing nothing is no longer an option. Things have already gone too far, so we need to take action. And today we're thinking about research laboratories. And actually these are workplaces that are more energy, water and material intensive than most work environments. Every day I'm using incubators, fridges, ultra-low freezers, fume hoods, and these all suck energy and use a lot of energy. I'm also using a lot of single-use plastic because that's kind of deemed to be the cheapest and most sterile way of performing my experiments. And so I really came to the conclusion that personally, a lot of my environmental impact is actually happening at work rather than at home. And so that's kind of why I wanted to make changes in my own workplace. And when I'm thinking about taking action sustainably in the workplace, I often think about these United Nations Sustainable Development Goals. And specifically, I think we would be thinking about goal number 11, which is about creating sustainable cities and communities, and also goal number 12, which is about responsible consumption and production. And I'll often talk about these goals and how they work when I'm looking at lab sustainability, just because they can help us to think about what it is that we need to achieve as a lab and also as a wider workplace, company, university. And so often if you're trying to justify why you're spending time or money on sustainable practices, it's worth bearing these global goals in mind as a way of convincing others to get involved and as a driving force for change. And a really easy thing for us to remember when we're talking about sustainability is reduce, reuse, recycle. And these are kind of the pillars or the foundations that we can focus on when we're trying to identify how to make our working environments more sustainable. And it's actually also important not to think of these three things as equal. And reduce is actually the gold standard and the preferred option. Then you think about reuse and finally recycle. Having great recycling schemes in place is important and useful, but not needing that thing in the first place or being able to reuse that item multiple times is actually far more sustainable than recycling it. So it's important to have all three of these, but really whenever possible, focus on reduce, then reuse, and then finally recycle. So I'm going to talk to you about these three different things in a lab context. And generally, I'm thinking about the waste that we generate in our labs, items that are highly energy intensive, such as fume cupboards, cold storage systems, and then also thinking about benchtop equipment that we have within the lab environment. So let's start with recycling. Household recycling is now really well established, and I would guess that a lot of your office workplaces have recycling bins and systems in place as standard. And this is a picture of the bins from my office in the Roslin Institute. And you can see there's three different options. This is pretty standard, I think. We have a blue option for cardboard recycling and paper recycling, an orange option that's more for plastics and cans, and then a black option that is for general waste and food waste. I think that's not really any major surprises, but when we then go to the lab space, I think recycling gets more difficult. And in my experience, something that is only just kind of being effectively implemented. At the Roslin Institute, we have cardboard recycling and plastic recycling in the labs, as well as general waste bins for items that are not needed to be disposed of via the biohazard route. However, there's often confusion over whether or not items can be disposed of to a recycling bin or whether they need to be in the biohazard. And often the reason that people state for that confusion is one of health and safety. So when I talk to people, often they say, actually, if something has entered the lab environment, is it not the best thing to do? Is it not just to put it straight into the biohazard waste? And this is really an area where you could step in as health and safety professionals and help researchers to make the correct decisions about where items can be disposed of. Biohazard waste is highly energy intensive because of its nature, because it needs to be decontaminated in a certain way. Whereas removing items from that waste stream and putting them into another waste stream, actually, that could make quite a big energy impact. So I'm currently helping to increase the recycling within the Roslin Institute alongside our campus's sustainability committee. And we have identified that this is an area where improvements could be made. And so I just want to talk you through this poster, which is it's a work in progress. It's not something that's been finalized. Just because I wanted to talk you through it, so then we kind of have a bit of thinking around why this could get more complicated in a lab setting rather than a workplace setting. So basically, we're trying to remove waste from the hazardous clear bag system and put it into an alternative stream route, waste stream route. So hazardous waste, obviously anything that has been infected with a biological agent has to go to hazard waste. But then we'd hope that there are items that are not contaminated and can be placed elsewhere. Paper and cardboard is obviously really obvious. If there's paper or cardboard, then that could go into a paper recycling. And general waste is usually for things that can't be recycled. So usually this is things for me that are like the bags that tubes, the plastic bags that tubes come within, they often can't be plastic recycled. Or the sleeves that stripettes might come in, they can't be recycled as plastics, they have to go in the general waste. Whereas anything that's plastic that has not been contaminated, in theory can be recycled in a plastic waste stream. However, we do find that some people are very reluctant to do that within the lab because they worry that the item is contaminated even if it isn't contaminated. So something that we're maybe going to do as a compromise is to have some kind of decontamination step to make people happier that that plastic can then be sent for recycling. But that's something that we're still kind of working through. One way to also increase recycling is to work with your suppliers. I'm giving one example here that I've used, which is a take-back scheme by New England Biolabs for their polystyrene freezer boxes. So it is kind of worth looking to see if there's anything you can do in terms of recycling that's actually already provided by your suppliers. It's just that you might not yet know about it. So to summarize recycling, I would explore how you could introduce recycling into your labs. If you already have recycling in place, then have conversations with people to make sure that it's working correctly. Are there more items that people could recycle, but they are unsure as to what can and cannot be recycled? And what we're seeing is that people would like to have clear information so they can feel confident in their recycling practices. And actually hearing that from health and safety professionals is actually really encouraging and reassuring for researchers. And just a note to say that you may need to confirm with your waste contractor to ensure exactly what types of plastic, for instance, that they are willing to take as recycling. So sometimes it's not as easy as you defining what can be recycled as plastic. Sometimes it is dependent on your waste contractor. And always remember that the biohazard waste is very energy intensive. And so being able to remove items from that waste stream and put them into a different waste stream does have a large environmental impact. So let's move on to reuse. As we just mentioned, hazardous waste is energy intensive for disposal. And the same is also true for hazardous chemicals. So hazardous chemicals often have a large environmental impact, firstly to produce them and then to ship them, and also in the disposal process. So making the best use of these materials is actually really important. And what you can do in this space will really depend on the setup of your lab and the type of work that's taking place. However, I think there are a few things that can be done to make best use of hazardous chemicals. Firstly, is there a way for you to help your colleagues to set up an inventory of the chemicals that they already have? This could allow researchers to know whether they need to purchase a chemical in the first place or whether they can use chemicals already purchased by someone else. I know that can often create a conversation around, well, who should be paying for that item then? But I would suggest really trying to push through that argument and instead discuss why this is so important for sustainability. Making best use of the chemicals already present within a workplace is really, really important. And secondly, you could also try and have conversations with your researchers about whether the hazardous chemical is needed in the first place. Health professionals really have a good knowledge of what chemicals are hazardous, and whether or not there are substitutes to use instead of those hazardous chemicals. So can you have those conversations to actually reduce the need for hazardous chemical in the first place? When thinking about equipment, a similar idea can be used. So everything that is purchased has an energy cost from manufacturing it in the first place. And so it should be treated as precious. And can you help to keep equipment purchasing down by creating it in a database, equipment database, so that researchers can see if they need to purchase a piece of equipment for the research or whether they can use one that's already available elsewhere? Can the equipment be redistributed once it's no longer needed by a particular person? These are all things that can help to reduce the energy needs of a research lab. At this point, I wanted to take some time to talk to you about a study that I was directly involved in at the Roslin Institute, looking at how we could reuse single-use plastic items in order to reduce the amount of biohazard waste that we were generating. I was only able to carry this out because the members of Ross Fitzgerald's group were really keen to take part in the study, and because we had the support of the Central Services Unit, who are responsible for processing waste and autoclaving. So let's start by really briefly thinking about the prevalence of plastic in our research labs. In any research lab, disposable plastic is everywhere. We use inoculation loops, culture tubes, petri dishes, tips, pipettes. They're all single-use plastic. And there's been a big increase in the public concern about how much plastic is being generated and disposed of. And even though there's a lot of help and advice on how to reduce plastic use in our day-to-day household lives, there isn't as much information available on how we can reduce that amount of plastic in research labs. There also hasn't been many occasions where researchers have tried to quantify the amount of plastic actually being used and disposed of. So I think a really important starting point for this project was initially to assess how much plastic we were actually using and how much waste we were generating. So in our lab of 7 researchers, we started measuring our plastic use over a 4-week period. And over that time, we disposed of over 2,000 plastic inoculation loops and tubes, generating a total of 97 kilograms of biohazard waste. That was quite a staggering amount of plastic for a month's work. So now that we knew how much plastic we were using and we had a baseline for comparison, we were able to look at plastic items and ask ourselves, what can we do to reduce this plastic? And generally, we took 2 approaches. We looked at replace and reuse. We identified some plastic items that could be replaced. So this included the introduction of reusable metal inoculation loops, as well as reusable wooden sticks that we could use for colony picking rather than using plastic tips for the same task. So for other items, we tried to reuse. So this was mostly for plastic tubes. We set up a decontamination procedure that allowed us to reuse plastic vacuum tubes. And we did this by combining a chemical decontamination station with autoclaving. And I'll take a bit of time now to talk you through that. So throughout the day, members of the group would empty the contents of their plastic tubes. We'd ensure that we correctly dispose of the liquid inside of them, and then we submerged them in a plastic tub containing 10% distill. And we would leave them at least overnight. The next morning, before any items could be added to the distill, we would remove the plastic tubes and rinse them. We would then leave them for the Central Services team to collect. And they would give the plastic another wash, and then they would autoclave them inside paper autoclave bags. These bags would be brought back to the lab, where we'd open them in a laminar flow cabinet and put the lids back on to the tubes for reuse. We wouldn't be performing this process every single day, but generally we will be generating enough plastic items that we'd carry out this process at least twice a week. And we generally try and share the workload between different members of the group, taking ownership each week. The final stage of screwing on lids back onto tubes was definitely something that was done as time allowed, so we'd be able to fit it in around all the lab managerial tasks. Once we had these new systems in place, we again measured how many plastic items we were using and how much waste we were generating. By implementing this cleaning and reuse process, we saved 1,670 plastic tubes and 1,300 plastic loops during a second 4-week period. And this led to a 43 kilogram reduction in waste, which was quite a dramatic reduction that we were able to sustain over a 7-week period. You can see in the graph that there is some week-to-week variation in the number of plastic items used. So each data point in the graph represents data for a different week. And generally, this was just because of the experiments that we were performing. Some weeks we'd use more plastic than others. Generally, we moved away from using universal tubes. That's why there's such a dramatic difference in the graph, because we weren't able to reuse those tubes. And so instead, we transferred to tubes that we could reuse, which were the Falcon tubes. Sorry, I'm just going to cough again. So using the cost of purchasing each plastic item and extrapolating it for a year, we estimate that we would save £1,615 a year, just as a group of 7 researchers from this reuse strategy. So this is just one example of the type of implementation that you could encourage and set up to allow researchers to make big changes to the amount of plastic that they use and the amount of waste that they generate. The items that we use regularly might not be relevant to your own setting, but I'm sure there is some form of plastic that you could implement a similar scheme for. So to summarize this reuse section, take time to identify how chemicals could be used more efficiently. This could be through a chemical inventory to reduce the amount of chemicals that go to waste, or are sat on shelves not being used. Can you help research to identify alternatives to chemicals that are less energy intensive to use but are still as effective? And identify a way for equipment to be repurposed and reused, and see if there are any single-use plastic items that could be reused using a decontamination. So this is going to move us on to our last most desired option, which is reduce. From my own study, it became clear that for us, we could move more and more toward reducing plastic items and substituting them for other things. And for us, I think that means substituting them for glassware. I'm particularly keen to investigate the use of glass petri dishes, because we go through a vast number of plastic petri dishes in our group. These can't be reused because they can't, they misshape in the autoclave. So moving to glass petri dishes would be a big change for our lab. That would be really beneficial. We could also move to glass culture tubes, glass pipettes, but of course, all of these things require initial outlay of money and cost to set them up, because we don't have those materials already present in the lab anymore. We used to. But yeah, and there's also now machines that would allow you to reuse plastic tips. One company that sells a machine is called Grenova, and I've just put their logo there just because that's one of the companies that I know of. But these, you can definitely purchase machines now that allow you to automate washing of tips for their reuse as well. Reducing energy usage is something that can have a massive impact in research labs because they're so energy intensive. You could do this by implementing a switch off campaign. So you could encourage your researchers to walk around the lab and to label pieces of equipment that should be turned off when not in use. Or maybe they should be turned off at the end of the day. Or some items may be able to say this has to be on all the time. For certain items that need to be on at set times of the day, you can introduce timer plugs. For instance, we have timer plugs on our water baths because these need to be on as soon as people arrive in the morning, but they don't need to be on overnight. So the timers help us to turn them off overnight. Fume cupboards are a really big energy user in the lab. So ensuring that researchers are using them correctly helps with health and safety, but it also helps with energy usage. So maybe creating some signs, ensuring people receive relevant training is a great way of ensuring that the fume cupboards are being used in the most energy efficient way. You could also train people and encourage them to turn it off to increase the holding temperature of PCR reactions. Often people leave their PCRs running at 4 degrees overnight, and it's just not necessary. 10 degrees would be absolutely fine, and it decreases the amount of energy that the machine needs to use overnight, and also actually it's better for the machine not to be holding the reaction at such a low temperature. One of the most energy intensive items in the lab is actually ultra low freezers. There's been a research project, a really good research project, looking at whether or not minus 80 degrees Celsius is actually required to maintain the viability of a lot of biological samples. And they found that mostly it was not the case, and that using minus 70 is actually sufficient to maintain the viability of the majority of samples. And increasing your ultra low freezers from minus 80 to minus 70 has a dramatic effect on energy usage for those machines. You can also encourage researchers to regularly defrost freezers and clean them out. This can also have a big impact on how efficiently the freezers run, as well as maximizing space. And things like cleaning air filters can also really make a difference to the efficiency of the freezers. And how the heating of the room in which the freezers are present can also have quite a large impact on energy usage. So when it comes to reduce, think old school. Are there items that can be replaced with glass? Short term, this might be an expensive approach, but the long-term benefits could be really significant. Try and set up schemes to encourage your lab staff to save energy. This could be by retraining staff in the correct use of fume hoods, or by encouraging equipment to be turned off when not in use. Freezers are a major source of energy use, and so taking time to ensure that these are being run as efficiently as possible could have really big impacts for your workplace in terms of energy consumption. I wanted to finish by encouraging you to start a sustainability initiative in your own workplace. And these are the simple steps that I would follow if starting a project from scratch. So firstly, identify where you can have the most impact. Maybe find some easy wins and also some harder long-term goals. Focus on all three areas: reduce, reuse, and recycle. Who are the key players in each area? So for recycling, you may need to engage with members of the waste department to make big changes, or maybe members of the facilities department may be needed to help you with reduce and reuse. So who do you need to work alongside to achieve impact in each of those three different areas? Always find a way to monitor the impact of any intervention that you make. So that way you'll be able to convince others to get on board and to adopt your changes, especially if there are cost savings long term. And then step back and evaluate. Maybe now that you've had some success, you can see what else could be done to make even more changes. I'll paste a link to the study that I performed on reducing plastic waste in case anybody would like to have a look at more details of that. It was published in Access Microbiology, and there's lots of information there on the exact plastic items that we know that we can reuse and alternatives that can also be purchased in. And then there's also details on the decontamination process that we used. I'd also really like to hear about any initiatives that you already have in your research labs in terms of sustainability. So do feel free to get in touch with me on LinkedIn or Twitter or via email. I'd be really happy to hear from you. I'm now just going to finish this presentation and actually take you to a short video that's been made by the Social Responsibility and Sustainability Department at the University of Edinburgh. Because it kind of summarizes a lot of the points that I've spoken about. So I think it'll be a really nice way just to finish off. And it'll give you a bit of time to come up with some lovely questions for me. And I really look forward to hearing your questions.
Edinburgh is a world-leading research-intensive organisation, and it has over 1,000 laboratories. These laboratories look into everything from medical breakthroughs to new technologies, new materials, and climate science. Laboratories can use 3 to 5 times more energy and resources than other areas of universities, and as such we need to take action in laboratories in order to make any kind of change. Sustainability in labs can mean a wide range of things. It can be small changes, such as remembering to switch equipment off at the end of the day and segregating waste, or it can be a whole-scale reimagining of how we teach and research science. It's a combination of these large and small changes which will lead us to the goals that we have relating to sustainable laboratories which deliver research which has a positive benefit for the world.
As biologists, the students and staff in this school have a deep passion for the natural world, and it's that passion that underlies our desire not to waste energy. People come forward with their own ideas, and they've been very willing to engage and volunteer in studies which we hope will change traditional practices in some of our laboratories. For instance, raising the temperature at which some of our freezers are run.
The Roslin Institute is a high energy user, but a very efficient building. On a day in the middle of summer, it uses £1,500 of electric a day, and at night or in cooler days goes back down to £1,000. This equates to roughly £3 per scientist per day. Any reduction in usage of equipment without impacting on science helps us reduce energy bills. And anything that helps us reduce costs allows us to put that money back into science.
There's a wide range of actions that we encourage our labs to take for sustainability. If they've got ultra-low temperature freezers, then we encourage them to defrost and clear out the freezer regularly and maintain it. If it's, for example, a chemistry lab and they've got fume cupboards, we would encourage the users to keep the sash down as much as possible, switch off the fume cupboard when it's not in use, because fume cupboards are highly energy intensive too. The other thing we can ask our academic community to think about is how to redesign the experiments they use in learning and teaching to reduce the use of hazardous chemicals, substitute them out, so that we're producing lower volumes of hazardous waste. The vet school is a great example of where learning and teaching are embedding sustainability into the curriculum.
Social responsibility and sustainability lies at the heart of veterinary medical education. Long term, we want to make the students who leave here as professionals aware of how veterinary medicine can change the environment. We're talking about every species from the ground up, so that they make those connections when they go out into the world.
There are many ways that staff and students across the uni can get involved with sustainability. You just need to check out our sustainability website and find out more.
Thank you very much, Emma. Thanks a lot. It was quite an insightful presentation, and I know we all learned a bit. We have a lot of questions to go through. So what I will do, I will read out the question, and you're very welcome to trace them in the Q&A session. Please add your questions. We are going to continue the session till 1 p.m. But if we don't answer any of your questions, there will be opportunity then for Emma to address it in the end. And these questions will be uploaded together with the recording and the slides. You will get a mail on how to access them once they are ready. So we will start with Ian's question about how do you work, Emma, with the suppliers of the plastic to develop more sustainable products?
Yeah, so it's a really nice question. So it's definitely something that manufacturers are thinking a lot more about. So I think a couple of years ago, probably nobody was thinking about this, but now you go to supplier fairs, for instance, and actually companies are kind of like, look, we're doing this, we're trying to make our plastic more sustainable, we're trying to make it more recyclable. I've worked with one supplier in particular. They were asking me to evaluate a new filtering system that used less plastic. So often it's a case of if people and suppliers get in contact with us to trial pieces of equipment or to give feedback on things, then I'm happy to do that. And yeah, but I think we have whole departments within the university that look at purchasing, and they also take this into account when they think about who do we want to purchase equipment from, who do we want to purchase anything from, even like things like pens. Like within the university as a whole, there's people that look into this and decide who the most sustainable people to purchase from are.
Thank you. David asked if it's safe to recycle contaminated waste.
Yeah, so the whole point there would be that you'd have to decontaminate it first. If you have anything that is contaminated, it has to be decontaminated before it could be recycled. or you would deem that it's past the point that it could be decontaminated, that it could be recycled. We're having conversations with our waste supplier is not the right word, contractor, to ask them actually if a plastic has been autoclaved and it's misshaped, can that still be recycled or not? And sometimes that's the important questions to have, because actually the process of recycling a plastic might mean that it's completely misshapen anyway within that process and melted down. So actually, if you first have to decontaminate something by autoclaving it, and it completely changes the shape, that may not mean that it can't then be recycled. So that's also things that are dependent on your contractor specifically, so that there is conversations to have with people.
And also it's probably depends on the type of waste and concentration, because all of us, we know about the waste management guidance, look at the recording, and it will explain what are mirror waste, what are always hazardous waste. So sometimes worth looking into it. Another question is from Lisa. Is the recycling handled by one waste provider?
Yeah, so ours is, yes. At the University of Edinburgh, yeah, our recycling is all processed by one company. But yeah, that'll vary company to company, university to university.
Which is good. What is, so how economically sustainable is to recycle contaminated liquid waste from laboratories?
It's a really good question, and it's one that's really hard to quantify, because it's a really good question, because you still have this process. So if I am decontaminating plastic and then also autoclaving it to reuse it, I'm using energy for the autoclaving process, and I'm also using water, I'm using chemicals to decontaminate, so that there is an impact to what you're doing. It's not that that's a completely zero impact process, and it's really hard thing to piece apart. So for instance, for us, we kind of wanted to tackle that question, but we couldn't really do that effectively, because it's really hard for us to say, okay, well, it's not that the autoclaves that day were only being used for our samples or our tubes, it was used for the whole institute. So it was really hard for us to piece apart exactly how much energy it was using to decontaminate. And it's quite a hard question. So I mean, that plastic would have had to be autoclaved in order to make it safe for disposal. So you're not removing that autoclaving process. I suppose the idea is that you're then reusing it, so you're not manufacturing a new one, and then you're not eventually throwing it away. But yeah, it's quite hard for us to
it should be assessed on the individual case. So for each recycling item, it should be considered, is it worth recycling? Yeah, so is it actually creates more waste during the recycling, the contamination? This is important too.
Yeah.
So there is a question about how to implement circular economy in the lab. I think that it's very rhetorical question. So if you do not have direct answer now, it's okay. We can skip it.
So I think setting up systems where if a piece of equipment is purchased and then it kind of serves a purpose for one group and it's no longer needed, having a system in place to move that to a new group who's then going to use it, or to a new group that's then going to use it, blah, blah, blah. Even things like computers. I know that within the University of Edinburgh, there's a system where computers that are no longer used within the university might be sent to schools, or might be sent to houses where they can't afford all the kids to have computers. Do you know what I mean? So that also, it's getting rid of the disposal step. Helps the circular economy, I think. And this idea of reusing plastic in the lab does help to think more circularly.
So, but there should be a more global approach from all combination of all processes.
Yeah.
So what happens to the general waste from the lab? As an uncontaminated waste, gloves, masks, if not recycled, can go in there if they are incinerated. So what do you know about general waste from the labs?
Yeah, so our general waste from the lab would be processed as if it was general waste from the office. So I'm pretty sure.
So it probably ends up in the landfill.
Landfill, yeah.
Landfill. Yeah. Okay. There is a question from Ajit, and he is asking, is IOSH assessment is conducted in the labs?
Yeah.
And Yes, you conduct COSH assessment because you're working with hazardous substances. It's required by law. Excellent. So Ron asks about infectious waste. Does this waste go through an autoclave before transporting to a waste incineration plant?
Yeah.
And the answer is yes. The next question is from Sue, and she's asking, how does the energy cost of washing or autoclaving tubes compares with the energy use for the manufacturing?
Yeah, I don't know the answer to that question.
Apparently, Saroj answered it, and there is a study published on it. So I believe that everyone can access the Q&A and look for the link from Saroj, but I pasted also into the chat. Please have a look, or everyone who is interested. And we have a next question. So did you look at the energy using for cleaning of Falcon tubes, additional energy for autoclaving? And again, the studies that I just published link to is covering this too, or at least should. So why is it the leads are not decontaminated together with the tubes?
Yeah, so basically we do decontaminate them as well. It's just that they're separated to make sure that the decontamination process goes for the inside of the tube as well as the outside of the tube, because that's where we need to decontaminate. And basically, if we autoclave lids attached to tubes, then they're more likely to change shape. If we autoclave them separately, it means that they can both be reused lots of times. So yeah, so actually having the lids not attached helps with the pressure within the autoclave, and therefore it helps everything to maintain its shape.
Excellent. So Jane asked if you can reuse the glass alternatives.
The glass alternatives, yeah.
You can.
So we do, the main glass alternatives that we already have in the lab are like flasks, conical flasks. We use them all the time, and actually, so the process for them is that they get straight autoclaved. So whenever they've been finished using, whenever we've used them, they don't get any deep chemical decontamination. They're autoclaved straight away, and then they'll be washed and given back to the labs. So yeah, so basically, yeah, glass can be treated without any chemicals.
There will be more questions about glass later on. So how do you decontaminate plastic hoops, as these were originally put in place to avoid the use of Bunsen burners and potential for splatter from the metal loops?
Yeah, so I maybe didn't catch all of that, but basically we couldn't reuse plastic inoculation loops because they don't survive the autoclave. So we transitioned to metal loops, which, yes, you're right. So we use the metal loops, we use them in a flame, and that's the way that we decontaminate them in between usage. Did that cover all of that question?
What is the comparison between the energy used for autoclaving, washing, compared to the energy involved in the manufacturing and disposal use of liquid waste going to drain? Yes, I think that partly it should be covered by the studies that Saroj probably. Thank you very much for sharing it. So it is next question. What was the increase of water and energy consumption? Okay, so maybe you can reflect from your own experience. Did you notice that there was an increase in water and energy consumption? Not probably as noticeable from you as a user of the laboratory.
Yeah, and because we had such a good reduction in the amount of waste we were sending as well, so there is a trade-off there. Like, because we were sending more things to get washed and reused through autoclaving, we reduced our waste, so there was less waste being sent for autoclaving before it was thrown away. So I assume in my head that they balance each other out, but I don't have concrete evidence to support that.
I see. It will be interesting to look through the study suggested.
Yeah.
Okay. Have you considered to stay in contact with the other labs within the university to reuse chemicals that you may no longer use? Do you have any kind of shared inventory?
So no, and it's something that I would really like my institute to have. So we have, where I work, we have communal weigh rooms where a lot of chemicals are stored. So the only thing that we have really is that in those weigh rooms, we can go to a list. There is an inventory on the wall telling you where you should be able to find certain chemicals. but I think I'd probably like that to be a bit more electronic. And also not all chemicals that everyone is using is put into the weigh room. So if somebody thinks something is particularly precious, maybe they won't include it. It's just not updated as much as it could be. But yeah, that's what we have in our setup.
My team has recently published a paper. I have just sent the link. It's about chemical storage and inventory management. So we are actually giving an example of how the sharing of inventory may be positive for everyone, and there are other aspects, so maybe it will be useful for people. So, okay, going back to Q&A, the next question is, have you considered, we changed the silicone cake cases away from the plastic dishes. Changed the silicone cake cases away from plastic dishes. Don't know. Doesn't ring anything. Next one is, how did you mitigate the sharp risk from biological materials that could occur from the reintroduction of the glassware as opposed to plastic? I promised another question about glassware.
It just doesn't happen very often. I suppose, at the point of usually the point where glassware gets broken is actually the autoclaving process. So things can usually get knocked at that point when actually they should be clean, then they're decontaminated. So I think it's not a common thing. You're right, there's more opportunity. So for instance, if I was growing a bacteria in a glass flask and I dropped it on the floor, it is more likely to break and smash everywhere than if it was in a plastic container. But I suppose you just be more careful. Yeah, I don't know.
Something for something, right?
Yeah.
Okay. So is there anything you're specifically looking into with respect to return the glassware to the labs? So for example, avoidance of cuts from the glass. So probably it's like, do you have any additional training, or do you have like reinforced glassware, or do you consider it as an additional risk?
Not really, no. So I mean, in terms of cross-contamination, there shouldn't be any increased risk versus using plastic items. Yeah, for instance, you can still buy plastic. You can buy glass flasks that have screwable lids. So that would prevent cross-contamination. But no, not really.
Okay, and the next question is, are you aware of similar studies in chemical laboratories rather than biological?
No, and do it. No, like, so when we started this project, I kind of looked to see what was out there, and there really isn't much out there that people have looked at or done. So actually anything that people do is all useful information. So it would be great to do more in different types of labs. So yeah, obviously I did it in the lab that I'm in, which is a microbiology lab. So that's what worked for us, but it'd be great to see what can be changed in chemical labs as well.
Okay. Oof, something happened to me. So thanks, Amy. You are having acknowledgement of your efforts here. And the question is, are you still working on other plastic wares that could be washed and reused other than tubes, wooden toothpicks, cuvettes, etc.?
Not really, no. For us in my lab, the tubes is what we use a lot of. That's what we focused on. But I think with anything, you just want to see what's being used most frequently in your lab. We did, so yeah, we tried to look at Petri dishes. That didn't really work because they don't they change shape in the autoclave, so we couldn't reuse them. Also 96mm plates we struggled to reuse as well, because again, for the same reason, we couldn't really fully decontaminate them in the autoclave because again, they change shape, they shrink. That also didn't really work. So I think for each workplace, it probably is quite obvious from what you're ordering in to know what your big plastic usage is.
Mhm.
And then I would try and see if you can reuse that plastic or not. And how you reuse that plastic, what you need to do to decontaminate it, etc., will depend on what you do in the lab as well. So it's kind of all about identifying what your biggest offenders are, finding a good way of decontaminating it to the level that you need it to be to then be able to reuse it. So I think it's going to depend lab on lab. And yeah, I think the big ones for us were tubes. So that's what we really focused on. And some of the tubes that we're using didn't withstand the decontamination process. And so actually we stopped using those and we used a different type of tube that did. So sometimes as well, it might be a case that you might need to slightly change your supplier to find a tube that then can withstand the decontamination process. And that's what actually will work really well for you. So yeah, in the case study that we published, the information on the exact tubes that we would use and stuff is all in there. If you wanted to swap to those tubes, then you know for sure that they can withstand the autoclave. But yeah, you might need to do a little bit of investigation yourself.
Great, thank you.
Which was quite fun actually, to send things to autoclave and see what they came back looking like. Yeah.
Okay, so you have described some great ideas and initiatives around environmental management considerations in the lab environment. However, what other sustainability initiatives have you considered, especially within the wider socio-economical areas? Question from Peter Rees.
Wider social economic. So yeah, there's loads of different things that people could.
Perhaps we will just forward Peter to this link that you gave with all the initiatives that is supported by the University of Edinburgh.
Yeah, and even within the sustainability department, they look at a wide range of things, like also in terms of like travel, business travel, like how we can be more sustainable in how we travel, which is quite a big thing actually. But yeah, so there's loads of different things out there.
Yeah, it's a topic for another session. So what is the most efficient way and less environmental impacts to dispose the hazardous waste?
You're really limited in terms of hazardous waste in what you have to do. So in terms of hazardous waste, you have to autoclave it in order to make it safe. There's no way around that really. So yes, that's all I'm going to say on that, I think.
Good. Next question is, how long would you recommend the laminar flow hood can be on without using it? 5 minutes, 10 minutes?
Yeah, personal choice.
Personal choice, but if you're not using it, just turn it off.
If you're not using it, you can turn it off, yeah.
I've heard that there is a special monitor that can see it when it's up for too prolonged time and then it starts to beep, so you have to bring it down, but I do not know details, so this is what I've heard. Okay, how to minimize and reuse the store waste? Store waste. No idea. No, we need more details on this, please. So the next question is, are you able to use opportunities where deliveries and collections can be managed so that it minimizes the carbon usage with more efficient use of transport? This is what you was also mentioning.
Yeah, so my institute is really good at this as well. We have like a central ordering system. So a lot of the main consumables of the institute are ordered in bulk to the lab, so then actually it reduces the amount of shipping, etc. But I realize that it's not always feasible in every workplace to make that work efficiently. But yeah, like stores departments and stuff can look into how to make the shipping more efficient.
Okay. Do you know if there are any studies on the stability of cells stored at -70 degrees rather than -80s over the long period?
Yeah, there is, and I don't have that to hand. But
So we will provide some links maybe once we are published.
Exactly, yeah, I can provide links after. But yeah, there is. I just haven't got that.
Okay. So question is, do you obtain metrics from your own in-house arrangements and from specialist waste contractors in order to review and evaluate your performance towards further improvements?
Quite a complex question. Personally, no, but I think we probably do as a whole, as a workplace, we probably do, but I don't personally know.
Not aware, I will write. So, do you build sustainable procurement into your purchasing habits? As an example, would be buying plastic made up from recycled or waste plastic.
Yeah, so again, the university as a whole do look at that, try and do that best they can. But like I personally don't do that. But as in like the university kind of makes that decision for me in as to who I am allowed to purchase from. Does that make sense? But yeah, so the university does look into things like that, yeah.
So sometimes in R&D environment, changing the behaviors of the scientists can be a challenge. Have you adopted any strategies to help with the engagement?
That is a really great question. I think training people is really, really important for a lot of sustainability. Changing people's mindset can be one of the biggest barriers to making change. So I think it's really, really important. So yeah, so I think we're currently thinking about that more and hoping to do more, just making people aware of things that they could be doing, changes that they could be making. Yeah, but yes, training is really important. So usually we have workshops, or there might be some posters to remind people of things that they could be doing. Occasionally we have campaigns at different times of years. For instance, we have like a winter shutdown campaign to encourage people to turn things off over the Christmas break and to defrost freezers before Christmas break when things are maybe less active in the labs. So that, yeah, there's different things that happen at different times of the year just to remind people of these sustainable practices. But yeah, I think people constantly need to be reminded and encouraged. Yeah.
Okay.
I think the positive thing to say there is that actually people are really keen to make changes right now. I think sustainability is such a big topic at the minute. But actually, if you want to try and do something, now is a really good time to do it and try to implement new things, because people are really interested and keen to do it.
We have 3 questions remaining and we have 1 minute. So first, how many times can you reuse the plastic tubes?
Lots. We've not really run out of, lots and lots.
Excellent. Do you have any experience with swapping plastic to glass in tissue culture areas?
No, not yet.
Excellent. Are you worried that reminders of the distill may compromise the next sample to be used with this tube?
Yeah, so that's why we actually wash them quite a good amount. So we wash them at least twice before we use them to try and get rid of the distill, yeah.
Thank you very much. That's all. Thank you all for attending our session. Enjoy your lunch. Thank you very much, Amy, for being with us and providing all this expertise and sharing good practices so we all can improve our own processes. Thanks a lot. I wish you all a very good day and thanks for this session. Bye, everyone.
Thank you, everyone. Bye.